Hello, happy campers. Let's start talking about chapter 2 in our textbook. We'll be talking about proof, and we already talked about what a proof is. Today we're going to talk about some logic, because remember, proof is when you take facts, you start with facts, and use logic to reach a conclusion. Okay, so you start with certain facts, you use logic, and then so today we're going to talk about what is this logic that we're going to use. What does that mean? So we're going to use learn some new terms here. The first one is conditional. What is a conditional? A conditional is quite simple. It's a statement that says if this is true, okay, then something else is true. Or, like we say, if P, then Q. Or P implies Q. If this is true, then this is true. Okay? So the hypothesis is whatever we say the P statement is. That's a hypothesis. And the Q statement is the conclusion. Okay? And so another way of looking at that is in a Venn diagram here. Okay, we have a circle. Your hypothesis, okay, is what's in here. Okay, this is your hypothesis. The conclusion is this big box out here. In other words, if a car is a Corvette, then it is a Chevrolet. Okay, Chevrolet. Okay, if a car, so this would be the Corvette, and this would be Chevrolet. Okay, so the big one is Chevy, the little one is Corvette. And we'll talk about a little bit more later on about the reversing those two. But this is called deduction, okay? Or deductive reasoning. And this is what Sherlock Holmes used. If you're a fan of Sherlock Holmes, or if you've ever heard about him or read anything by Sherlock Holmes, this is what he did. This is what he used. In fact, one of the famous lines from Sherlock Holmes is, "Brilliant deduction, my dear Watson." So let's start with something new here. We say an equilateral triangle, by definition, has three congruent sides. Okay, a isosceles, now please pay close attention, triangle, at least, most people leave this out, two congruent sides. So most people leave that out and they say, well, it has to have two congruent sides, it can't have any more. No, it says at least two congruent sides. It means it's an isosceles triangle. So we're going to make a statement here. If the triangle is isosceles, or excuse me, if it is, better erase this stuff. If a triangle is equilateral, then it is isosceles. So what we're saying is equilateral implies isosceles. Okay, and so we're saying ABC, triangle ABC, is equilateral. So what does that mean? Well, triangle ABC is isosceles. Well, how do I know that? Because if it's equilateral, it's going to be isosceles. So we're going to make a fancy little Venn diagram here, and we're going to show you how this whole thing works. And not that fancy, it's kind of crooked, but okay. This big one is isosceles triangles. This is all the isosceles triangles in the whole world are in this big rectangle. This one, okay, is equilateral triangles, okay? And this little doodad right here is triangle ABC. So you see triangle ABC is equilateral. That means it's also isosceles because all equilateral triangles are isosceles. The reason we build it this way, it's called a Venn diagram. I think you know this. The reason we build it this way is because there are some isosceles triangles that we all know about that are not equilateral. They just have two congruent sides, but they don't have three congruent sides. But all equilateral triangles are isosceles because they have at least two congruent sides. So, that being said, let's move on. And what's a converse, okay? Converse means the opposite. We reverse the conditional. What do you mean we reverse the conditional? What the heck does that mean? That means if P implies Q, then the converse, this is a conditional, okay? The converse is just the opposite. Q implies P. Well, how does that work? Well, let's try one. Let's say if an animal is a snake, notice this is a hypothesis, this is the P, then I'm going to get rid of that because I don't like that there. Okay. Then the animal is a reptile. Sorry about that. I ran out of room. So if an animal is a snake, then the animal is a reptile. Okay? That's the conditional. Okay? Well, we're going to look at the converse of that. Okay? And the converse says if an animal is a reptile, then the animal is a snake. Now, this is the converse, okay? Now, notice when I did the conditional, if it's a snake, that's P, then it's a reptile, that's Q. Here, I did the opposite. I said if it's a reptile, that's P, then it's a snake, that's Q, okay? So, P implies, excuse me, this is Q, we'll keep it that way, Q, and this is P because it's a converse. So Q implies P, that's the converse, and so if it's a reptile, then it's a snake. Now at this point, some of you are probably squawking and saying, wait a minute, what about a turtle? Okay, a turtle is a reptile and it's not a snake. Okay, what you have done just now, you've given me a counter example. Okay, counter example is something that disproves a conditional or a converse. Okay, now the conditional is true. Okay, this is true. Because if an animal is a snake, then it's a reptile. The converse of that is false. Okay? If an animal is a reptile, then the animal is a snake. That's not true, because a turtle is a reptile and it's not a snake. So a turtle would be a counterexample to prove that this statement is not true. Okay? Got that? Now, we got more fun, and this is called logical chain. Okay? Logical chain. Okay? So, I want to prove that if it's Thursday, I have a big smile. Okay? Now, you're probably wondering, what are you talking about? Well, I'm going to make 3 statements here. Okay? The first one is, if it's Thursday, that means I'm in a good mood. Okay? And if it's test day, then it must be Thursday. Okay? And if I'm in a good mood, then big smile. Say, what do you do with all this stuff? Well, first of all, you got 3 different statements here, 3 different conditionals in a row. We're going to have to rearrange these conditionals so that they make some sense. And the way we do that is we just look for connections, okay? Like, for example, good mood, okay? And here's another one. Let's see, Thursday and Thursday, okay? So those are the connections we can make. So let's see, I don't see it. Nothing comes before test day. So let's start with test day, okay? So we got test day, and that means it's Thursday. Okay, and then Thursday means I'm in a good mood. Okay, and then we have good mood means I have a big smile. Okay, so look at what I did. I just took this statement and put it up here. I took Thursday means I'm in a good mood and put it here. And then good mood means I have a big smile and just put that right there in the bottom again. Okay? So what does this mean? You see, if it's test day, start with this. Then it goes to Thursday. And if it's Thursday, then it goes to good mood. And if it's good mood, then it goes to big smile. Okay? And goofy squares. Okay? So what we have is test day and big smile. Okay? And so, oh dear, I've made a mistake. I should have put if it's test day. I'm so sorry. It's late at night. I'm trying to get this done before so please bear with me. Once in a while I make a mistake. If it's test day, then I have a big smile, okay? So test day, big smile. There we go. And so this is what we're trying to prove, and guess what? I just proved it. I started with these are the facts, okay? I used logic right here. This is called a logical chain, okay? And there is my proof. So the proof is test day gives me a big smile. That's all for now. Thanks.